you all for coming to Jazz Dev Day. We are very excited to have a global audience for this webinar. That this is a series of webinars that we're conducting, more importantly, to raise awareness around serverless and also to help you accelerate adoption of serverless using Jazz. We have a packed agenda today. We'll talk about what is serverless, but more importantly, why serverless? Why should you consider serverless as a key component when you're building applications in the cloud? In that context, we will introduce you to Jazz and talk about how Jazz can help you with your serverless journey. We'll do this through a working demo using a scenario that a lot of folks on this call will be familiar with. We will then have you try out Jazz right in the call. You should be receiving an email with the details about how to try out Jazz. And while we are doing that, we will also open it up to Q&A. So what is serverless? Serverless is an evolutionary computing paradigm. I think the main concept over here is you can run your applications and services without explicitly provisioning or managing the servers. So that looks like a lot of words. So let's see if we can simplify that using a picture. So this here is the cloud evolution. And in here, we have two main actors. The first one is the application owner, which most of the folks on this call might be. Like you could be an application owner, a developer who is in charge of developing some component, right? And then there is the infrastructure provider. In the far left is the physical model that we usually are familiar with, right? This is your on-prem deployment for your application. While you as an application owner is responsible for writing the code for what your application should be doing, you also have to work with your on-prem, infrastructure provider to make sure that they procure the machines where your code can run, where you can, and you specify to them what host OS you need and everything else, right? You know, what kind of runtimes do you need on that, any dependencies that you have, you make it part of a release document or some install script. And then on the far right is serverless. So the key difference, I think, this in this picture we're trying to help you raise awareness is, as an application owner, your boundary is, this is, I just want to write my application code. And all this rest of the stuff that you were trying to coordinate with this other team, right, on-prem, which sometimes, like procuring the machines, can take weeks to months and sometimes even quarters. You have to plan ahead of time. Now, with the cloud computing, the serverless model, you no longer have to do that. You no longer have to do that in the sense it's the cloud provider's responsibility to make sure that you have the latest updated patched machines on which your code is running, as well as it can scale as and when your load increases, as and when your users are using your application. So we're going to elaborate on that as we go through a demo, and probably it will become more clear. So now we're going to talk about like why serverless. Right, we briefly looked at the picture. It starts making sense. Like basically, hey, as an application owner, don't have to worry about procuring the machines and stuff. But I think if you were talking to a client, if you're talking to a customer, or if you're talking to even within your team, there are two main reasons that you want to talk to them and sell them on serverless. The first one is going to be cost. The big part of why there is a cost savings with serverless is you never pay for idle capacity. Now, if you think about this, you never pay for idle capacity. It could be in production because you're provisioning machines because you're expecting a certain load on your application. But it could also be your dev, test, pre-prod infrastructure. You're provisioning all those machines. They're sitting there for your devs to handle, but then I think it's all cost to the business. So that's one big part. But the second one is with serverless, you never have to plan ahead as to how much of usage are you going to get out of those machines. So if you happen to have much less traffic than you anticipated, you're only paying for what you're using, and then you're also paying in terms of increments of 100 milliseconds. Now that could mean like significant reduction in your cost as you start thinking about why I want to go serverless. Uh, the second main reason I think you want to talk to your clients, your business partners, or within your team is agility. As we saw in the previous picture, a lot of, you didn't have to manage machines. Like nobody had to procure the machines. Nobody had to update them, patch them. Now that reduces the overhead on the overall team, right? So your team can go from POC to prod within a matter of a day if you require. Like you don't have to plan it out for quarters. And we're going to see that through a demo too. Horizontal scaling. This is basically you wrote the code once, and now this code can run for 1 request per second all the way to planet scale, and you don't have to do anything. Like literally, you don't have to manage any configuration or scripts to achieve that. In a lot of ways, that horizontal scaling is how I believe the cloud had to be built in the first place. Uh, the third big reason I would say on agility you hit upon is high availability and fault tolerance. Now, with engineers on this call, you all know how hard of a problem that is for any application. For you to build a highly available fault tolerant application, it takes a lot of engineering expertise. Now, that is out of the box for anybody who goes to serverless. You don't have to do anything. Like there's no configuration again for this. Now, as we think about why serverless, I think we're going to talk about like who are the main players in this over here. There's Lambda, Azure Function, Google Cloud Function, Apache OpenWest. So now that we've talked about why serverless, you might be thinking like, how is Jazz related to serverless? So Jazz is an open source product. As product can help you create serverless services like you can create APIs, you can create functions, you can create websites. But with this combination, you pretty much can build a lot of end-tier architectures that you might already be running either on-prem or in the cloud. Your instance of Jazz, so let's say you installed Jazz today, your instance of Jazz will have, and this is going to be your own instance, you will have built-in registration and authentication. You guys are going to experience that as you try out Jazz. You're going to get you're going to get an email with a registration code, and you can log in. This is how your customers, your users of Jazz within your enterprise are going to be using it. You will this inbuilt instance of Jazz is going to come with templates for Node.js, Java, Python, built-in CI/CD, isolated environments. If you're doing true multi-feature development, logs, monitoring. So this list here is more or less things that were gaps in the serverless solution that the cloud providers offer to you. In a lot of ways, Jazz actually works together with serverless and helps you quickly get there building your applications. So with that, I think I mean, that's a lot of talk. I mean, I think some of it might make sense, some of it might not. So we're going to try to do this through a demo, right? We're going to, go through a scenario that most of us might be experiencing as we write some of these applications, right? You would be thinking about a POC. Your stakeholders come in, they come in and they say, hey, we want to build this POC. This website needs to have these screens, and we need a middle tier, we need a backend that it can connect to. So as you start thinking about this POC, you're going to be procuring a machine. This most likely is going to be like a desktop sitting on, a desktop of your own, or maybe a machine on-prem, or maybe in the cloud too. But you need to get a machine for this, right, where you're going to be hosting this POC. You will map out the dependencies. You will be patching and updating that machine that you just procured, making sure that it is up to date, right? You're going to be securing the machine. Then you can start writing code, right? You're now starting to write the code to build your POC. And then you're going to build, you're going to deploy, you're going to iterate on this over and over again. right? And make sure that this is how the POC was envisioned and the stakeholders are happy with it. As you go through this process, you're going to go through the stakeholder sign off on it. You're going to go to pre-prod environment, and you're going to do the same things, but it's going to be a different set of machines. Like, the POC might be on your local machine. This pre-prod environment will be a staging environment, or whatever you might be calling in your world, right? You're going to procure more machines, right? You're going to map out the same dependencies, patching, update, security. Again, you're going to be write code. So here, write code could be, you might have a feature branch, you're going to be released, you might have a release branch, you might be pushing it there, but you're still publishing code somewhere, right? And that's getting built and deployed. So that's your pre-prod environment. And now when the stakeholders are again, the users and the stakeholders sign off saying, yep, this is the application that we're thinking about, you now start thinking about how do I take it to prod, right? You would be thinking about, what is the anticipated load? How many users are we expecting? What are the peak loads are going to be? And based on that, as engineers, we will have to come up with what are the number of machines we need, for the website, for the front end, for the middle tier, for the back end. You're going to have to plan for traffic spikes. There might be days where you get more load than others. I mean, think Black Fridays or anything else, right? Then you again will be doing the same dependencies, patching updates, security, and you're releasing code, which is write code here, right? And then you're going to still go through the build and the deploy. As you go through this process, you now have got it to prod, well, fine, but you spend probably months or multiple quarters on this. Now we're going to try to see how we're going to build a similar POC and how we're going to take it to prod using Jazz. So with that, it's demo time. When you install Jazz from GitHub, right, this is where you go to GitHub T-Mobile Jazz. We're going to send you, we'll be sharing you these links at the end of it, but it's a single command line that you run. And when you run it, you're going to get a Jazz home URL. You're going to use that URL to register. And as part of the registration, you're going to provide your email address. So this could be a developer within your org, right, who's going to be providing their org email address, a password, and a registration code. Since I've already registered, I'm just gonna go ahead and log in with the email address that I registered with. So a couple of things happened over there, right? Jazz was able to, like the built-in Jazz, this is the first time you're going to be experiencing Jazz, and it comes in with built-in authentication. And it already knows that I created a service, like, probably like an hour ago. But since part of the demo, we're going to be building a POC. So part of the POC now, I envision I need to give this product a name. So I'm just going to call it my cool demo, right? So the product, the POC product is called Cool Demo, right? And I need a website for this one. So here it's asking me, what do you want, API, Lambda, or website? I'm just going to use a website because I need to create a website as part of the POC. I'm going to say my website, okay? So those are the only two questions that it's asking me, and I can hit the submit button. There are a few other things that we don't need to worry about during this demo, but we're just going to click on submit. Now when I click on submit, it's actually going through a CI/CD process behind the scenes. It's validating that I have the right permissions, the input arguments are correct, but more importantly, it is actually now talking to AWS, and all of this has been configured as part of your setup. When you install Jazz, it's going to ask you about your AWS account, credentials and stuff. So it is using that to now deploy the website. So while that is happening, because it's saying creation started, I also need, for as part of this this cool demo product, I need an API too. So I'm just going to say my API, right? So, and that's all I need. I can choose a runtime. I can choose Node.js, Java, Python. I'm just going to choose Node.js here, and I click on submit. Okay, it says it's creating the service. Well, awesome. So while it's doing that, I see that the website that I created, it has turned from creation started to creation completed. So let's try to explore that more. When I click on that, it's showing that the prod deployment is still in progress, stage is in progress, but I see an hyperlink over here, which is the Git repo. When I click on that, what I get right now is a templatized code for me to start writing my website application. So again, what happened over here? I just gave it my website as my POC app that I wanted to write. And what Jazz did behind the scenes is it used template code, with some of the best practices that I might have, right? Within my org. Like within my app, I need a CSS folder, fonts, images, JS, and this is how, the best practices team has put this together. Now, this is something that you can change to suit your organization needs, but this is what Jazz comes by default. But of course, because it's open source, you can templatize this to what your organization does best. Also see that I have an index.js because this is all Node.js code. I have an index.js. So what I'm going to be doing is I'm going to start working on a branch from here. So I'm just going to create a feature branch called F1, right? I'm working on this cool new feature. And while I do that, I am in the interest of time, I'm not going to do git clone. Usually you would want to do git clone on your local machine and stuff, but we're just going to use the online one just to edit. So I need a lot of log statements, so I'm just going to uncomment that so we start logging. But I'm also going to say this version is my feature F1. Again, this is template code, doesn't do anything. This is a sample response that is going to be sent back from the Lambda. Again, you don't have to worry about a lot of this stuff because we have already wired all of this together for you. A lot of the best practices that we have learned, the internet has learned, has been put into practice in this template code. But behind the scenes, when I edit this, what I am trying to do is I'm saying my version of the API, my API is going to return as part of the response, another key called version, and it will have F1 in there. So I'm just going to commit the code so that it gets deployed. So now I have two feature branches, or I can check on branches for you. It has F1 and master. We're just going to come back over here and see what's happening. So it has now changed from creation completed to active. So we're going to try to explore what does active mean over here, right? It says my prod deployment has happened. So this is my template code that got deployed to prod, and the deployment status is it's active. But one other thing I want you guys to notice over here is it actually detected that I created a feature branch F1. So I created a feature branch F1. I, as a developer, created a feature branch F1. Jazz detected that, and it's now trying to deploy even the feature branch out to your own environment. And we're going to see what that means because it's still trying to deploy, as you can see. But let's explore what prod does here. So when I go to prod, I click on it, I actually get an endpoint over here. So let me copy that to clipboard, and let's try to see what does this do. So this is now an active API. This API is actually functional, and I think I can prove that to you even further if that wasn't is equal to alpha. So it's the input action, the input object is gonna just keep expanding what what my input is. So this is a live API now. And now going back to the slide, so like what we talked about here, this API works for 1 RPS, so 1 request per second. But guess what? Because of the way serverless works, this API is now prod ready. What I mean by that is now this API can scale from 1 RPS all the way to planet scale without anyone from your team actually procuring more machines, without anyone from your team actually going back and tinkering with any scripts to say, how am I going to load balance? How am I going to do failover? How am I going to do any of the other things that you always have to think about? So this API now is good for you to give to anybody to say, this is deployed to prod, go ahead and play with it. And it has a different, This URL is specifically for prod, and we're gonna try to see what do I mean by that. So the F1 branch is still getting deployed, but I think it is almost there. Okay, looks like it is already there. So this was the feature branch F1. Remember we did version is equal to alpha 1. This one, it doesn't have version in there, but my feature branch F1 had. So let's try to click on that. So you see now I have a different dev working branch, right? I have a dev working API for my feature branch F1 active while my prod is also active. And for both of these environments, the prod as well as my feature branch F1, I didn't have to provision a single machine. I didn't have to tinker with any scripts. I don't have to worry about patching, updating, downtimes, or any of that. It just works, right? We're going to go back and look at my website too, see where that is. So website deployments with AWS, because of the way AWS CloudFront works, it can so CloudFront is this technology from AWS where you deploy your websites to the edges. Now, because there are a lot more edges than there are regions, it takes a lot more time for AWS to actually make sure that it's available everywhere. So we're gonna try and see if AWS has completed. If not, we have a different one that I just picked up earlier. Actually, AWS was fast this time. So this is a working version of a website again. Now, the same principle applies over here too. I have this website now can take load of 1 RPS, so 1 request per second, all the way to planet scale without I, as a developer, ever having to talk to the infrastructure guy, the DevOps guys, or to anybody about, hey, I actually missed our performance of our website said, so I need 5 more machines. You don't have to have that conversation. Of course, you want to fix when you have performance issues, but right now it's just going to be an increased bill on AWS. But what you don't have to do is, your users getting 404s or whatever, 5x6, whatever else might be, because your website is under load, right? And I can do a similar thing again with a function too, but I think we're just gonna turn over let's try to explore a few more features before I turn back to the slide deck. So what we did earlier was we saw the different branches and we also executed them. So let's explore what does prod here mean. I think you're gonna see deployments. You can click on the deployments. You can also, like, you as a developer can click on build now. It's gonna kick off another build for you. But if I go back, I actually have this section called logs. Now when I click on logs, it actually doesn't find any logs, but that's because I'm looking at prod. And remember, I uncommented the lines about lines of code only in the feature branch. I did not do it in the prod environment. So let's go to the feature branch and let's see, does it have any logs? And it does. So I can look at all the logs. I uncommented those lines of code. So there's nothing interesting with logging, but these are just basic logs. So Jazz is not only collecting, is not only just deploying your application, your website, but the out of the box behavior for you is it's actually going to capture all the logs from your application, whether it be Node.js or function, and have them captured back in within Jazz. So for your developers, all this means is you actually click on only one button, create service. You configure it over here. I, as a developer, would get a repo within which I work. I work or I create branches within it to run the code, and Jazz takes care of just deploying it to your target environments. So with that, we just now gonna go back to the scenario that we had, right? The POC, pre-prod, prod. Now, if we did this using Jazz, you didn't have to worry about like all of those other things, right? All of that is taken care of in partnership with Serverless. So it's not just Jazz which is doing it. Some parts, Serverless is doing it, like the procuring machine, dependencies, patching, updates. But Jazz is taking care of build, deploy, some overlaps with security, logging, monitoring. All of that is built in. So you as a developer just write code. So with that, I think I'm gonna have you guys try out Jazz, and by this time you should be receiving an email with details about what Jazz, how you can try out Jazz. So the email is going to have two details, so that you're clear about it. When you log, it's going to give you a URL. So let me log out. It's going to give you a URL, right? As part of the URL, you're also going to get so launch, go to that website. Once you click on the URL, you're going to click on the login button, and when you click on the login button, do not click on the little register button at the bottom and use your email address, right? So I'm just going to return use my other email address just to register, so that you know what I'm talking about. I'm just going to use a password that is works for Jazz. I'm just going to use the registration code, and you would get a verification email that would be sent by your email. You click on it, and once you click on it, you will be able to log in using your email address and your password into Jazz, and you should be able to create services. Contribute to Jazz. We're looking for more open source contributions. We're looking for folks who have specific scenarios, that they want to solve with serverless, or they have a different set of components that they want to work with. Currently, Jazz works with Bitbucket, GitLab, Jenkins as our CI/CD, and AWS specifically. But we're looking to expand that, and I think we'll talk about the roadmap. So we're looking for contributions. So if you have a scenario, we want to partner with you to make sure, I think, Jazz can meet your needs, but more importantly, as a community, we grow this product to help each other out. And so as part of the Jazz roadmap, we are building new service types. You saw API, function, website. We are integrating more IoT scenarios. We want to build, more multi-tier architectures as one type. So you can get both the website and the API and maybe a backend as part of one template. We're also trying to, have more templates which will be available for Alexa skills, right? So bring your use cases. We want to learn from your use cases and use them to build more of these service types. Multi-cloud is going to be next. So Azure Functions is coming very soon. But again, we're looking for partnerships. Google Functions, Kubernetes, real-time alerts, versioning rollback, Blueprint deployments, local testing and debugging. This is a call out. Like, what do you need? What are your serverless, opportunities that you see? How can we help you? How can we pair up? Go to github.com, T-Mobile Jazz, and at the very bottom, you're going to see this try Jazz. You can also register over here, by joining the Slack channel, and you can get a registration code, which will enable you to try out Jazz at your pace at a different, time.